another episode of Math in the Wild, where we look for the concepts that you learn about in class out in the wild world around us. Now today we are focusing on Euclidean geometry basics. Now Euclidean geometry is different from the other types of geometry because it focuses on flat space. So the first thing we are going to look for is a point. Now according to Euclid, a point is that which has no space, but we denote it with a dot. And look, crikey, there's one now! We get up close. It's a dot marking a point. And what it sits on here, we can consider a plane, a flat surface in which many dots or lines can sit. So now we've seen a point and a plane, but the last and crucial part of Euclidean geometry is a line. And if we look here, we can see various lines all intersecting. Now an intersection is a point which lines cross. So now we are going to go look for some parallel lines, which is the basis that makes Euclidean geometry Euclidean. So if we look here, I have two lines that never touch. These are parallel lines. Parallel lines can be seen in a variety of things. So if we continue down, here are parallel lines cut by a transversal. Now, parallel lines cut by a transversal have special properties. Some of the angles inside of them are congruent. So here, when we have two angles like this, these are vertical angles, along with these ones. We also have some angles called corresponding angles. So if I look here, and I look here, I have corresponding angles. The area between this and this are approximately the same. So, we've seen the vertical angles and the corresponding angles. Now we have to see the alternate interior angles. Now interior means inside the parallel lines, and alternate means on opposite sides of the transversal. So, this angle right here and this angle right here are congruent. So let's go and see what else we can find out in the wild. Here we go. So right here, we see an angle. Now, because of how wide this angle is, we know that this angle is obtuse, which means it is larger than 90 degrees, but smaller than 180, because being 180 would make it a line like this, right here. Oh look, over there, quick! Here we see the right angle, creating that nice square look. Now right angles are among the most common angles we see every day and don't even know it. Notice that right here is 90 degrees. So let's see if we can find an acute angle to go with our obtuse and right. So, right here, I see a very tiny angle between the tree and the branch. This is an acute angle. If it had gone to this one and been like that, it would be right. Notice that it is less than 90 degrees. So, let's go see what other things we can find. One of the hardest things to find in the world around us are triangles. So come this way, and right up here you can see a right triangle. Notice that its corner forms a right angle. So now we are going to be looking for some basic shapes. And if you look right here, we have a circle. Now a circle has 360 degrees. In a circle, if we can find the diameter going from here to here, we would know the area and the circumference. Now the area of the circle is the equation pi r squared. The circumference of a circle, the equation is 2 pi r. So, moving on, we're going to be looking for other math phenomenon shapes in the world around us. It looks like right over there we might have another. So here we have a square. Now a square has 4 90-degree angles and all the sides are the same size. So when we take the area of a square, we multiply the side times the side. So in this case, if we count all of this as 1, it would be 1 times 1, making this 1. Now if we look at this as a bigger picture, and we take 1, 2, 3, 4 squares, we can find the area. So if we count this as 1, 2, making this side 2, and this one is 1, 2, making this side 2, the area is 4. Now notice that there are 1, 2, 3, 4 squares in our larger square, thus confirming our area. So let's move on and see if we can find anything else. So here we see a 3D shape. It's a circle on top, but all the way down this would be considered a cylinder, making it a 3D object. So let's go and see if we can find anything else. So we are looking for a sphere. Now we have come to a pool table where not only spheres congregate, but various angles as well. So we are going to sneak up very, very quietly to see if we can catch a pool player. So here is our pool player. Now we are going to have to sneak up very quietly to make sure that we do not spook him in his natural environment with the spheres and the angles. Let's see if we can get a closer look to the action happening on the table. Notice how he made a bank shot. So let's see if we can get any closer to the action. Crikey, we've scared him away! They have scared our pool player away, but he left behind his spheres for us to look at. Now notice that a sphere is just a 3D circle. Magnificent, isn't it? Now on a pool table, the goal of this is to roll it and hope that the angles you use bank it into a shot. I am not very good at pool, because I am not the elusive pool player. There it is, angles at work. Magnificent. So this week on Math in the Wild, we have learned a lot of things. We have learned
about points, planes, a line, parallel lines, an obtuse angle, a right angle, an acute angle, a right triangle, a circle, a square, a cylinder, a sphere.
Thank you for joining us this week on Math in the Wild, where we covered Euclidean geometry basics. Join us next week when we talk about algebra. Yes, you do use it every single day.